Today we're going to learn about substitution or elimination. Which one do you use and when? Substitution is when one of the variables' coefficients is 1 or -1. Otherwise, you use elimination, by multiplication specifically. And we're also going to talk about elimination using addition or subtraction, and you'd use this when it can eliminate one of the variables immediately. In our examples, we have the variables x and y. You know you can use substitution when the equation starts with an x equals or y equals. Because the x and the y variable are already solved for, you can use substitution and plug it into the other equation. This first problem is a good example of that. It already has solved for y. It's given that y is equal to -3x plus 1. So because we know what the value of y is, since it's alone on the left-hand side, we can simply plug that value into the second equation. So we're going to get x plus -3x plus 1 is equal to 9. So this is going to be equal to -2x plus 1 is equal to 9, which is going to be equal to -2x is equal to 8, since we subtract 1 from both sides, and then we can divide by -2 on both sides, and we're going to get x is equal to -4. Again, we have to plug in x back into one of the equations to solve for y, so we'll do the second one here, because it's a lot more simple. So we're going to have -4 plus y is equal to 9, and after adding 4 to both sides of the equation, we're going to get that y is equal to 13. So our ordered pair is going to be -4, 13. How about the second equation here? Are we going to use substitution, elimination, or addition or subtraction using elimination? So we see that, first of all, none of the variables' coefficients are 1 or -1. So let's think about if we can use elimination. We see that there's a common variable, 2y, in both of them. And so we can actually eliminate the y's from the system of equations. So that means we're going to use addition or subtraction. Because one of them is negative and one of them is positive, all we have to do is add the equations together, because we're going to get 4x and the 2y's cancel out. So it's going to be plus 0 is equal to 12. And we're going to get x is equal to 3. Now again, we can plug this back into the equation, and we're going to get 3 minus 2y is equal to 10. Subtract 3 from both sides, we're going to get -2y is equal to 7. So y is going to be equal to -7 over 2. And again, the ordered pair is then going to be 3, -7 over 2. How about this last one here? This last one, we see that the coefficient isn't 1 or -1. And also, we can't eliminate one of the variables immediately. So addition or subtraction is also out of the question. So that means we have to use elimination by multiplication. Now we see that since all the variables are lined up, we have 4y and 2y. We see that the easiest way to make one of the variables have an equivalent coefficient is by multiplying the bottom equation by 2. Because if we multiply 2y by 2, it would be 4y. So let's multiply this by 2, and we're going to get 2x minus 4y is equal to 24. Now let's write the top equation, and we can add them together. 7x, the 4y's cancel out, perfect, is equal to 35. And we're going to get x is equal to 5. Plug it back into the equation. We get 5 minus 2y is equal to 12. If we solve for y, we're eventually going to get y is equal to -7 over 2 again. So our ordered pair is going to be 5 and -7 over 2.